second order partial derivatives. For a function of two variables z as a function of xy, if the first partial derivative with respect to x and with respect to y is also a function of two variables, this means that each of the functions partial derivative f with respect to x, partial of the f with respect to y has two partial derivatives, provided that they exist. We call it the derivative is formed by the limit of the different quotients. These four partial derivatives or partial derivatives are called second order partial derivatives, or just called second partial derivatives. And these can be denoted by the following forms. In the parentheses here, that's the first partial derivative. And then when you find the derivative on top of it, it's called the second order partial derivative with respect to x, and the shorter notation is f subscript 2x. If you find the partial derivative with respect to x first, and then find the second order partial derivative by doing the derivative with respect to y later, the notation will be f subscript x and then subscript y. Similarly, partial derivative of the z with respect to y, which is f subscript y, and then you find the derivative with respect to y on top of it. So you just add another y to the subscript of the notation. When you find the partial derivative of the z with respect to y first, or the f of y, and then find the partial with respect to x later, you just put the x in the back there. Okay, so the order is kind of the backward. Let's look at the example. We're gonna find all four second partial derivatives of the function of x and y. That means we are going to find f subscript of x, and then f subscript of y, and later we're gonna find the partial derivative with respect to on top of it, and partial derivative of the y on top of it. First of all, we find the first order partial derivative. So first order. That means f subscript x. We find the partial derivative of the function 3xy plus x squared times y to the third minus 12 with respect to x. When you do with respect to x, we're going to treat x as the variable. The rest is going to be treated as a constant term. So the first term going to be 3 times y. The second term going to be 2 times x and y to the third as a constant. Negative 12, the derivative going to be 0. Not 0. Therefore, we simplify to be 3y plus 2x y to the third. And then the partial derivative with respect to y of 3xy plus x to the second, y to the third minus 12. We're going to treat y as the variable. The rest is going to be the constant term. The first term going to be 3 times x. The second term going to be x to the second times 3y to the second, and then minus 0. Or simplify to be 3x plus 3 times x squared y squared. Now the second order. For the first order with respect to x, we're going to do partial with respect to x on top of it. So we do the partial derivative with respect to x of 3y plus 2 times x times y to the third. Treat x as the variable, the rest as the constant term. So going to be 0 plus 2y to the third, or 2y to the third as the second order with respect to x and with respect to x. And the next one, the second order of the one with respect to x and with respect to y. So partial with respect to y of the f subscript x, which is 3y plus 2xy to the third. We're gonna treat y as the variable and the rest is gonna be constant term. The first term, the derivative is 3. Second term gonna be 2 times x times 3y to the second, or it becomes 3 plus 6 times x times y to the second as f subscript x subscript y. The next two is from the partial derivative with respect to y, and then we do the partial with respect to x on top of it. From what we got, f subscript y, or the partial derivative with respect to y, is 3x plus 3x squared times y to the second. With respect to x will be treated as the variable. Then the first term gonna be 3, second term gonna be 3 times 2x times y to the second, or becomes 3 plus 6 times x times y to the second as f y x. And the last one, f subscript y, or the partial f with respect to y, and then find the partial with respect to y on top of it. Then we find partial with respect to y. We're going to treat y as the variable. The rest going to be the constant term. The first term going to be 0. Second term going to be 3x squared multiplied by 2y. And then simplify to be 6x squared times y as partial derivative of the y, and then with respect to y. And if you write in different notation, I'm going to use different. So this one is the partial of the x of the partial of the x, and we can write as the partial second partial derivative of the f with respect to x. This one is the partial of the y of the one that already with respect to x. So we write it as partial y partial x. This is the partial derivative of the x of the partial with respect to y. We can write it as the second order partial derivative with respect to x with respect to y. This partial with respect to y of the partial with respect to y.